The Weapon That Broke the German Army. A monolithic narrative, December 17, 1944. The Ardennes Forest, Belgium. Obergefreiter Hans Müller crouched deep in his frozen foxhole, the soil around him smelling faintly of pine needles and spent propellant. He was a veteran, hardened by the unrelenting grind of the Russian front, and now tasked with one final, impossible push in the West Hitler's Wacht am Rhein, the last desperate gamble to reverse the tide of history. His task, a seemingly simple one, was to keep advancing. But the words he etched into his diary that day, with numb fingers and a racing heart, spoke of an enemy that defied all his experience and training. The Americans are not like the Russians. Their artillery is something else entirely. It is not the volume of fire, though that is terrible enough. It is the speed. It is the accuracy. It is the knowledge that you have no time to react. One moment there is silence, the next moment the world explodes. Through the dense, chilling fog that shrouded the landscape, Müller's battalion, a spearhead of the 6th SS Panzer Army, had initially achieved their objective. Complete surprise against thinly held American positions. The German assault had shattered the enemy's forward screen. Victory, fleeting and illusory, seemed within reach. The plan was sound, the element of surprise total. Then the American artillery found them. What Müller did not know, what no German soldier advancing through those snow-covered forests could have known, was that they were about to encounter the most lethal and technologically sophisticated artillery system ever deployed in warfare. It was a system that functioned not on intuition or experience, but on pure industrial mathematics, a machine so precisely coordinated and devastatingly rapid that it would break the back of Germany's last offensive and reveal the true fatal depth of American military, industrial, and intellectual superiority. The collapse had begun long before the first snow fell on the Ardennes. For years, German doctrine had been forged in the crucible of the East. Veterans transferred from the Ostfront carried with them assumptions bred from battles against Soviet artillery. They knew how to survive a Russian bombardment. The Soviets, relying on mass, quantity, and often slow field calculations, would fire deliberate ranging shots, granting German troops precious seconds to seek deep cover. The subsequent barrages would arrive in predictable, sequential patterns, allowing movement between concentrations of fire. The Soviet fire direction was often agonizingly slow, demanding 10 to 15 minutes from the initial observation of a target to the final impact of a salvo. Survival was a matter of discipline, digging, and waiting. The Americans were different. They were terrifyingly different. Gruppenführer Otto Schmidt, a veteran of 2 years on the Eastern Front, captured in Tunisia in May 1943, described his first encounter with American firepower in a post-war interview. His account was a symphony of shock and disbelief. We had taken position in a wadi north of Tunis. Good cover, we thought. The Russians would have needed an hour to find us and another hour to range their guns. We felt safe enough to heat our morning coffee. Then we saw it. A small aircraft no bigger than a reconnaissance plane puttering overhead at perhaps 500 meters altitude. We barely paid attention. Such aircraft had no weapons. We assumed it was doing photography. 3 minutes later, without warning, without ranging shots, without any indication whatsoever, the entire wadi erupted. Shells landing simultaneously, not in sequence. Air bursts above us, ground bursts among us. In 30 seconds, my company ceased to exist as a fighting unit. I was one of 11 survivors from 123 men. The foundation of this terrifying speed was the Fire Direction Center, FDC, a concept that completely revolutionized the employment of field artillery. German batteries calculated firing solutions individually, relying on the skill and experience of a single officer at the gun line. American batteries, however, fed all observation and meteorological data to a central FDC, which could then coordinate and calculate fire solutions for dozens of batteries simultaneously. This centralization was the key to speed and accuracy, but the FDC system depended on a monumental pre-war industrial effort. Pre-computed firing tables. In vast, quiet offices across the United States, far removed from the dirt and confusion of the front, rooms full of women, often brilliant mathematicians, known simply as computers, worked tirelessly with mechanical calculators, slide rules, and logarithm tables. Their task was to calculate and record firing solutions for every conceivable combination of atmospheric and ballistic variables. Wind speed and direction, temperature, humidity, propellant temperature, barrel wear, and altitude differences between the gun and the target. These comprehensive leather-bound tables, printed in books small enough to carry in a map case, allowed American fire direction officers to calculate precise first-round effective firing solutions in minutes rather than hours. Lieutenant Friedrich Bauer, an artillery officer who had coordinated German counter-battery fire on the Eastern Front, documented his professional astonishment in letters discovered decades later in German military archives. "I studied American artillery procedures from captured documents. Initially, I believed these documents were deception, propaganda designed to intimidate. No artillery system could perform as described. The coordination required would be impossible. Then I witnessed it myself. Before we could move, before we had even computed firing data for counter-battery fire, American shells were landing on our position. Not random fire, not area saturation, precise fire on each gun." Hedman Werner Hoffmann, a mathematics professor conscripted into the Wehrmacht artillery, examined captured American firing tables after the war. His analysis, preserved in German military records, revealed his stunned appreciation. These tables represent years of computational work, thousands of hours on mechanical calculators. They had computed solutions for every variable we might encounter in the field. Our own firing tables were crude by comparison, requiring extensive field calculations for each mission. The Americans had done the mathematics in advance. In the field, they simply looked up the answer. But tables alone could not explain the American artillery's most devastating quality: the utter lack of warning. That secret lay in a technique so advanced, it fundamentally changed the experience of combat. Time on target, TOT. Time on target, coordinated artillery fire so precisely that shells from multiple batteries, some firing from just a few kilometers away, others from a distance of 20, would all arrive simultaneously within a 3-second window. The technique required meticulous coordination, precise calculations for each gun's unique muzzle velocity and range, and an almost clockwork-like discipline in execution. The effect on the receiving end was catastrophic. German soldiers experienced no ranging shots, no gradual build-up of fire. One instant, silence. The next instant, dozens, sometimes hundreds, of shells detonating at the exact same moment. This sudden, overwhelming violence eliminated the most basic survival instinct of the infantryman: to drop prone at the sound of the first explosion. Studies conducted after the war revealed that 66% of artillery casualties occurred in the first few seconds of a barrage. TOT maximized casualties by eliminating the warning period entirely. Troops caught in the open had no chance to react. Stabsfeldwebel Kurt Zimmermann, who survived TOT strikes during the Battle of the Bulge, recorded the visceral terror in his diary. "It is not artillery as we understand it. It is something new. You hear nothing. Then the world ends. Every shell arrives in the same second. The air bursts kill men who would survive ground bursts. The ground bursts kill men who would survive air bursts. There is no time to dive for cover, no time to reach a hole, no time even to drop flat. You are simply alive one moment and wounded or dead the next." This operational speed, the ability to transition from silence to instant coordinated devastation, was further magnified by communication superiority. American forward observers used new, rugged FM radios, like the SCR-610, that provided clear, static-free communication. German forces still relied primarily on older AM radios, plagued by interference, shorter range, and a massive logistic tail. Every American infantry battalion had multiple radio-equipped forward observers who were trained not as separate artillery specialists, but as integrated members of the combined arms team. German battalions typically had 1 or 2 radios, often shared between units, with artillery observers who were often disconnected from the daily reality of the infantry. The crucial difference lay in scale. An American forward observer, a lieutenant or captain living in the foxhole with the rifleman, could call upon an entire corps' worth of artillery. This pyramiding of firepower meant a single rifle company surrounded in a village could, within minutes, bring down the weight of metal equivalent to a small airstrike, delivered more accurately and more rapidly than any air support could provide. Lieutenant Heinrich Müller, commander of an infantry regiment destroyed near St. Lo in July 1944, documented this capability in his final report. A single American infantry company, surrounded in a village, held my entire regiment for 6 hours. Every time we attempted to assault, artillery fire drove us back. Not from one battery, but from what seemed like dozens of batteries. The forward observer with that company commanded more firepower than I could bring to bear with my entire regimental artillery. We lost 400 men attempting to overrun 120 Americans. We failed. The eyes of this instant destruction belonged to the L-4 Grasshopper. These single-engine, high-wing monoplanes, essentially militarized Piper Cubs, were unarmed, slow, and flew low. But they provided the crucial instantaneous observation link that German artillery, relying on fixed observation posts and slow-wired communications, could not match. German soldiers quickly learned that the buzzing sound of the Grasshopper overhead was the prelude to the end. The L-4 pilots were specially trained artillery officers, masters of map reading and quick calculation, able to radio precise corrections to the FDC the moment a shell landed. The German system, by contrast, was rigidly organized. Corps and Army artillery were separate commands, not readily available to support divisional operations without extensive coordination and approval through multiple headquarters. A German platoon leader might wait hours for fire support, routed through division to corps, often arriving too late to matter. American doctrine emphasized responsive, immediate fire, but the sheer volume and mobility of the American guns demonstrated a deeper, more fundamental advantage, unmatched industrial superiority. The M2A1 105mm howitzer, the American standard, was a triumph of engineering and manufacturing. Rock Island Arsenal had perfected production techniques that allowed rapid manufacturing to precise tolerances. By the end of the war, 8,536 M2A1 howitzers had been produced. Each American infantry division had 36 of these guns, organized into 3 battalions of 12 guns each. These battalions were fully motorized, towed by powerful trucks or half-tracks that could move at highway speeds. Displacement from one firing position to another, an evolution that took German horse-drawn artillery 2 to 3 hours, took American motorized batteries 20 to 30 minutes. The contrast in mobility was stark and decisive. The German army remained shockingly a 19th-century army on the move. Despite the ubiquitous image of the mechanized Panzer Division, approximately 80% of German motive power for transport and logistics relied on horses throughout the war. Germany started the war with 514,000 horses and ended it with nearly 1.2 million. Each German light artillery piece required 6 to 8 horses and took hours to limber, move, and unlimber. In mud, snow, or under fire, movement became nearly impossible. Grief writer Paul Richter, assigned to a German artillery battery in Normandy, kept a detailed diary that survived the war. We watched American artillery displaced during a battle. They fired their mission, then trucks appeared. Within 20 minutes, the entire battery had limbered their guns and departed. We required 2 hours minimum to perform the same evolution, and that assumed good weather and roads. In mud or under fire, we might need 4 hours. The Americans would set up at a new position and be ready to fire again before we had finished moving. We were fighting a 19th-century war with horses against an enemy, fighting a 20th-century war with trucks. The outcome was inevitable. Even these divisional assets paled beside the artillery available at corps and army level. Battalions of 155mm guns, 8-inch howitzers, and the massive 240mm howitzers weapons capable of destroying any fortification. The pyramiding of this firepower meant a single rifle company could, within minutes, bring down the destruction of a siege battery. The final decisive technological marvel deployed against the German army was not the gun itself, but the fuse, the variable time fuse, or VT fuse, known to the Americans as the proximity fuse and to the Germans as the demon shell. The VT fuse was a top-secret marvel of electronics, one of the 3 most critical ordnance inventions of the war, alongside the atom bomb and radar. It contained a miniature radio transmitter and receiver in the nose of the artillery shell. As the shell flew, the transmitter broadcast a radio signal. When the shell approached the ground or any object, like an aircraft, the reflected signal triggered detonation. The result was a shell that exploded at the optimal height for maximum lethality, typically 10 to 20 meters above the ground. The VT fuse transformed artillery effectiveness. Conventional time fuses required calculating the precise time to target, then setting the fuse accordingly, a process susceptible to error from wind, temperature, and barrel wear. Even small errors meant shells exploding harmlessly too high or burying themselves in the ground before detonation. The VT fuse eliminated these variables, guaranteeing an optimal airburst regardless of conditions. It had first been used in combat by the US Navy in 1943 against Japanese dive bombers, and later in the defense of London against V-1 flying bombs, where it proved 3 to 4 times more effective than conventional fuses. Concerns about the technology falling into German hands prevented its use in ground artillery over Europe. The rules were strict. It could only be used over water or in self-defense against V-1s. However, the crisis of the Battle of the Bulge changed everything. As German divisions punched deep into the thinly held American lines, General Dwight D. Eisenhower personally requested permission to employ VT fuses against the massed German ground troops, arguing that their effectiveness justified the security risk. The Pentagon initially hesitated, but Eisenhower protested vehemently. Formal authorization came on December 19 through 21, 1944, marking the first use of VT fuses against ground troops in the European theater. The decision proved correct. VT-fused shells devastated German formations caught in the open. The lethal fragment area of a shell using a VT fuse was estimated at 3,000 square feet, compared to just 60 square feet for a conventional fuse. Troops who had learned to survive conventional artillery by seeking any depression in the ground discovered that VT fuses negated such cover. The shells exploded above them, showering downward with deadly fragments that struck men prone in shallow holes. Obergefreiter Hans Müller, whose diary chronicled his experiences in the Ardennes, survived a VT fuse barrage and recorded his experience. We had learned on the Eastern Front to go flat at the first explosion. Even shallow depressions offered protection from fragments traveling horizontally. But these shells, these demon shells as we called them, exploded above us. The fragments came down like rain. Men in foxholes, men who should have been protected, were killed by fragments that fell vertically. There was no defense except deep bunkers, and we had no time to dig deep bunkers. We simply died. The psychological impact of the VT fuses compounded their physical effects. German soldiers trained for years to respond to artillery by seeking cover found their training irrelevant. The knowledge that no cover short of deep overhead protection would save them induced paralysis. Some units refused to leave defensive positions, even under direct orders, because movement in the open meant certain death if American artillery engaged them. Corporal Friedrich Bauer documented a near mutiny in his unit during the final weeks of the Ardennes offensive. My company was ordered to attack an American position 300 meters distant. The men refused. They had seen what American artillery did to troops in the open, especially with these new fuses that burst in air. I tried to explain that we would die anyway if we did not attack. The men would not move. They preferred the possibility of capture to the certainty of death under American artillery fire. The sheer scale of industrial output ensured that this terror was constant and overwhelming. While German production, hampered by Allied bombing and resource shortages, struggled to maintain minimal daily allowances of ammunition, American factories produced artillery pieces and shells at staggering levels. Rock Island Arsenal alone produced over 10,000 105 mm howitzers. Ammunition production reached levels that allowed American forward observers to call for fire without restriction. Lieutenant Werner Vogel, the German artillery officer, documented the despair in his war diary. We received 50 shells per gun for the entire week, 50 shells to support an infantry regiment facing continuous American attacks. I was required to justify each fire mission to battalion, explaining why this particular target merited expenditure of irreplaceable ammunition. Meanwhile, American artillery fired thousands of shells daily with no apparent concern for conservation. We fought a poor man's war against a rich man's enemy. The Ardennes offensive, Germany's final major attack in the West, demonstrated these dynamics with brutal clarity. German armored and infantry divisions achieved significant penetrations, but the moment the fog lifted, the moment American artillery found them, the advance stalled. During the entire Bulge campaign, 4,155 American guns fired 1,255,000 artillery rounds. German units that had penetrated 50 kilometers into American lines found themselves trapped, surrounded by American forces that could call upon unlimited artillery support. General Franz Halder, former chief of the German General Staff, wrote in his post-war analysis that the sheer destructive power and rapid response of American artillery were the single most decisive factor in the defeat on the Western Front. We were defeated by American artillery before we were defeated by American infantry or armor. Every movement we made was observed by their aircraft and engaged by their artillery. Every concentration of forces was broken up by artillery fire before we could attack. Every defensive position was smashed by artillery before their infantry assaulted. We could not move, could not mass, could not defend. We simply absorbed artillery fire until we ceased to exist as an effective force. The German prisoners of war who witnessed American industry and training in the United States saw the true source of their defeat. Hedman Werner Hoffmann, the mathematics professor who had analyzed the firing tables, was captured in the Ruhr pocket in April 1945. His final military report, written for American intelligence officers, provided a chillingly professional analysis of American artillery effectiveness. The American artillery system represents the culmination of industrial-age warfare. They have applied industrial methods, mass production, standardization, and systematic training to create a weapon system of unprecedented effectiveness. Individual German artillery pieces may be superior in design. Individual German artillery officers may match American skill, but the Americans have created a system that does not depend on individual superiority. Their system produces consistent, overwhelming, rapidly delivered firepower regardless of individual skill levels. This systemization represents a revolution in warfare that Germany never matched and could not match. The sounds of the American artillery were not just the sounds of exploding steel, they were the final deafening pronouncement of an industrial colossus winning the war. By the spring of 1945, the thunder of American guns had become the defining voice of the Western Front. When the German lines finally broke, they did not collapse in dramatic armored clashes or desperate last stands, but in silence crushed beneath a continuous methodical rain of steel that left nothing to resist with. Entire divisions dissolved without a single decisive battle. Communication trenches disappeared under landslides of dirt and splintered timber. Supply convoys vanished, leaving behind twisted remnants of wagons and burned-out trucks. The survivors, dust-covered, deafened and hollow-eyed, wandered toward captivity as if emerging from a long nightmare. At the heart of this relentless advance was a rhythm, not of chaos but of order. American artillery was not the roar of instinct or vengeance, it was the pulse of industry. The guns spoke in mathematics, their language precision, their grammar repetition. Every salvo, every time-on-target mission, every adjustment by an unseen observer was the expression of an empire built not on conquest, but on coordination. When German officers were interrogated after the war, many confessed the same truth in different words. We were defeated by organization. For centuries, wars had been contests of courage, leadership, and chance. But in the Second World War, courage was no longer enough. The man in the foxhole could not outfight a shell that knew the exact second and meter of his existence. The tank commander could not outmaneuver a firing table calculated years before he was born. And no general, however brilliant, could match the collective intellect of a nation that had turned arithmetic into annihilation. Behind the front lines, this quiet revolution continued unseen. In factories across the United States, production never ceased, 24 hours a day, 7 days a week. Women riveters, machinists, and clerks moved through endless assembly lines like arteries feeding a living machine. The fire direction centers, the computers, the factory workers, the truck drivers, all part of a single organism that could project destructive power across oceans and continents. It was not heroism that won the war, though there was plenty of that. It was system, a cold, tireless system that turned ingenuity into firepower faster than any enemy could comprehend or counter. In the ruins of Cologne, a German artillery captain named Dietrich Keller stood beside his captured battery and told an American correspondent, "We fought you with men. You fought us with a civilization." His words captured the essence of what had unfolded. The Battle of the Bulge, the crossing of the Rhine, the fall of the Reich, all were chapters in the same revelation. That modern war belonged not to the boldest, but to the best prepared. When the guns finally fell silent in May 1945, the arithmetic of destruction ended. But its echo, the logic, the method, the discipline that had built it, became the foundation of the new world. In every steel mill, every laboratory, every radar station that followed, the lesson endured. The future would belong to those who could think faster, calculate better, and organize more completely than their enemies. The weapon that broke the German army was not forged in a foundry, it was forged in thought, and its roar would echo through every war to come.